As manufacturing techniques were refined through the 1930s, aircraft quickly became bigger and bigger. It was only a matter of time until aviation pioneers were trying to push the limits of size. Soon, large aircraft development would begin to outpace engine development, resulting in unfathomably large aircraft being powered by 8 or even 12 engines. But when limited to piston technology, what's the size limit? Today we're going to go over some of the largest piston-driven aircraft ever built, covering designs pushing the limits of piston-powered aircraft. Welcome to the Index of Oddities, where we discuss the lesser-known and more unconventional designs that often go forgotten in the skies of aviation history. In the early to mid-1930s, the U.S. Army Air Corps initiated an experimental program to develop a new generation of heavy bomber with unparalleled range and payload capacity. The result would be two projects known as Project A and D. Project A would call for an aircraft with a range of at least 5,000 miles and a payload in excess of 8,800 pounds. Project D would be a bit more ambitious, calling for a range of 10,000 miles and a payload of 16,000 pounds. Three companies would rise to the challenge, with projects submitted by Boeing, Douglas, and Sikorsky, the latter of which never left the drawing board. Boeing's submission was internally known as the Model 294. Upon submission, it would earn the name XBLR-1, standing for Experimental Bomber Long Range. Soon after, it was redesignated XB-15 in 1936. The design would include numerous advanced innovations, including two auxiliary petrol engines acting as 110-volt AC generators, sleeping and cooking facilities, de-icing equipment, and a primitive autopilot. The wing was large enough to include a service tunnel, allowing flight engineers to access the engines directly even in flight. The aircraft would be designed around the Allison V3420 liquid-cooled engine. This engine was effectively two V1710s with a common crankcase, though there were few common parts between the two engines. The V3420 showed a ton of promise, demonstrating a power output in excess of 2,000 horsepower. However, as was common with these experimental engines, development did not go smoothly, and the engine could not be delivered in time for the XB-15. While wooden dummy Allison engines would be fitted in the mock-up of the XB-15, the actual aircraft would be fitted with the lighter but weaker R-1830 Twin Wasp, producing between 850 and 1,000 horsepower. While not ideal, these engines were adequate enough to allow the aircraft to set a 1939 world record for weight-carrying capacity, taking off with a gross weight in excess of 71,000 pounds and reaching an altitude of 8,200 feet. It would also set a record for carrying a payload of 4,400 pounds over 3,100 miles. In terms of size, the aircraft was an impressive 87 feet, 7 inches long, and 149 feet wide. While not the largest aircraft in the world, a title which belonged to the Tupolev AN-T-20, the XB-15 was the largest aircraft built in the U.S. at the time. By September of 1937, the XB-15 would finally be complete, 4 years after the initial Project A proposal. The maiden flight would occur the following month, on October 15th. By December, it would be flown from Seattle to Wright Field in Ohio to be delivered for testing by the U.S. Army Air Corps. Performance-wise, it could achieve a maximum speed of 197 miles per hour without a payload. A cruise in the same configuration was only 152 miles per hour. This was nothing impressive, even by 1937 standards. Even worse, when fully loaded, the XB-15 could only reach a maximum speed of 145 miles per hour. This would eventually result in the termination of the project as it was deemed too slow and unsuitable for combat. However, its weightlifting capacity saved it from the scrapyard, at least for a few years. At the time, it was capable of lifting an 8,000-pound payload, more than any other aircraft available. In 1940, the XB-15 arrived in Panama to begin classified bombing tests. Only 150 bombs would be dropped, of which only 3 would actually hit the test target. Later that year, it would conduct a survey flight from Panama over the Galapagos Islands before returning to the United States. For an experimental aircraft, it was quite well traveled. By 1943, all defensive weaponry would be removed, and the aircraft would once again be redesignated, this time as the XC-105. It would also earn the nickname Grandpappy. During the Second World War, the XC-105 would carry freight and personnel between Florida, Panama, and throughout the Caribbean. Over the next 18 months, over 500,000 pounds of cargo and mail and 5,200 passengers would be transported on the XC-105. In December of 1944, a series of in-flight engine fires would ground the aircraft permanently. The plane would be scrapped in 1945 and eventually dumped into a swamp around Albrook Field, Panama. The area has since been developed into an industrial area where the remains of the XC-105 still reside under the surface. While the XB-15 itself was a mixed bag of impressive engineering and disappointing performance, its legacy did not end with the termination of the project. Lessons learned while developing such a large-scale aircraft would play an important part in the production of the B-17 and B-29. Even the Boeing 314 Clipper would benefit, as it used essentially the same wing, though a few feet greater in wingspan. In response to the aforementioned Project D, Douglas submitted a design designated XBLR-2, which would be later redesignated XB-19. With a wingspan of 212 feet and a length of 132 feet, it would be the largest aircraft in the world at the time of its construction. Empty, the aircraft would weigh 86,000 pounds, a full 16,000 pounds heavier than the maximum takeoff weight of the XB-15. It had provisions to carry a gargantuan 18,700-pound payload internally and could double its payload with externally mounted bombs. It could accommodate a crew of 24, 16 active, 2 flight mechanics, and a 6-man relief crew. The initial proposal for the XB-19 included the use of 4 Pratt & Whitney R1830 twin Wasp engines, the same power plants used on the XB-15. In theory, the twin Wasps would have been capable of getting the aircraft airborne, if only just. Later, the plans would change to accommodate the Allison V3420 liquid-cooled engine. Mirroring development of the XB-15, the engines were still not ready for use, requiring yet another redesign, this time settling on the Wright R3350 duplex Cyclone, capable of producing in excess of 2,000 horsepower. At the time, the engine was still in its infancy, and the XB-19 would eventually become the first aircraft to fly with the engines equipped. The project would run well over budget and behind schedule, and Donald Douglas himself would attempt to have the project canceled. However, the Army Air Corps denied his request, insisting that the aircraft continue development. Douglas recognized that, despite being the largest and most complex aircraft ever built at the time, it had fallen so far behind schedule that it was already obsolete. In fact, 2 months before its maiden flight, Northrop and Convair had already secured contracts to develop the XB-35 and XB-36 respectively. The XB-19 was scheduled to take its maiden flight on May 17, 1941. However, this was delayed due to problems relating to its sheer size. During ground trials, the aircraft proved to be so large that the ground beneath its landing gear would crack under the weight. As such, the runway surface needed to be repaired and reinforced. It was at this point that the engineers realized that the runway itself simply was not long enough to allow the aircraft to take off, further delaying the maiden flight. The runway would be extended by 4,000 feet, which proved a time-consuming and expensive modification, as it required rerouting a main road. By June 27th, the aircraft was finally ready to take its maiden flight in front of a crowd of 45,000 spectators. Despite the modifications to the airport surfaces, the XB-19 once again cracked the surface. The runway itself proved more resilient, so the crew were given the go-ahead for the flight. The XB-19 would depart from Cloverfield, California, flying only 22 miles to Marchfield for delivery. During flight testing, the XB-19 demonstrated a top speed of 224 miles per hour and a cruise speed of 135 miles per hour. However, the duplex Cyclones were prone to overheating, forcing the aircraft to fly with its cow flaps permanently open. This reduced the maximum speed to a pitiful 204 miles per hour. Much like the XB-15, this was much too slow for an operational combat aircraft. While the aircraft's career as a bomber was over before it even started, it did see use as a flying laboratory. At this point, the Boeing B-29 project was under development, and the R-3350s were crucial to the project, resulting in the XB-19 serving as a test bed for the engine through early 1942. By 1944, the Allison V3420 engines finally became available, and were fitted to the aircraft, at which point the aircraft was redesignated XB-19A. These engines did away with the cooling issues present in the radials, and even provided a significant boost to performance. The new top speed was 265 miles per hour, and cruise was 185 miles per hour. This put the new performance within the same playing field as the Boeing B-17. After the war ended, the Army Air Force no longer had any need for such a large and outdated aircraft. It would perform its final flight in August of 1946. The airframe would be tucked away in storage, initially marked for museum preservation. However, by 1949, it would be signed over for salvage. To this day, two wheels from the main gear assembly remain on display. One can be found at the Hill Aerospace Museum, and the second is located at the National Museum of the United States Air Force. While the XBLR program itself proved a failure, both the XB-15 and XB-19 played an important part in the war effort. Experience and data collected during the XB-19's career proved critical in development of the B-29 and future large-scale aircraft. Design work on what would become the Martin Mars began in the mid-1930s when the Navy was in search for a new long-range patrol bomber. Martin would submit their Model 170, designated XPB-2M1 Mars, and would earn a development contract for it in 1938. Development would proceed quickly, and the first airframe would be completed by 1941. The Mars would become the single largest active-duty flying boat in the world. With a wingspan of 200 feet and a length of 117 feet, it was only slightly smaller than the XB-19 we just discussed. It would be noticeably lighter, though still weighing in at an impressive 75,500 pounds empty. The Mars would be powered by the same Wright R-3350 engines found on the XB-19 as well. It could achieve a maximum speed of 221 miles per hour and cruised at 190 miles per hour. On September 27, 1941, the XPB-2M1 would roll out of the hangar for the first time, and come November, it was launched from Martin's Middle River plant. Over the next few months, various system tests were conducted while anchored. During these tests, on December 5th, the No. 3 engine experienced a catastrophic failure as it caught fire and launched the propeller blade through the fuselage. In an attempt to save the airframe, the anchor was removed and the aircraft was intentionally run aground. Luckily, the engine eventually fell free of the fuselage and the fire was quickly put out. Surprisingly, repairs were completed within 30 days of the incident, and by January 2, 1942, the aircraft would be towed to the seaplane ramp for final testing. Before the maiden flight, the Mars would undergo a few minor changes. Primarily, the engines were swapped out for a slightly more powerful version, and the wooden propellers were swapped with metal Hamilton standard props. By June 23rd, the Mars was finally ready to take flight. Flight tests would be continued throughout 1943, by which point the patrol bomber role, for which it had been designed for, was considered obsolete. Martin would modify the Mars, converting it into a heavy transport aircraft under the designation XPB-2M1R. The Mars would spend the next few years flying for the Pacific Naval Air Transport Service out of Alameda, California. During this period, it would complete 78 round trips between the San Francisco Bay and Honolulu before the Navy retired the prototype in March of 1945. The prototype would transport over 3 million pounds of supplies and personnel and was a critical asset during the fight for Iwo Jima. Satisfied with the performance of the XPB-2M1R as a transport aircraft, the Navy placed an order for 20 units and redesignated the aircraft JRM-1. The earliest production version would be delivered in June 1945, but with the end of the Second World War, the Navy would reduce their order to a total of 6. The production JRM differed from the experimental XPB-2M in a handful of ways. The prototype was essentially envisioned as a scaled-up PBM Mariner, inheriting the classic H-tail configuration. The JRM would replace that with a larger single tail. As it was built as a patrol bomber, the prototype included a number of defensive turrets, which were removed on the JRM. The wing structure remained largely the same, however the fuselage and hull were modified extensively to improve performance and carrying capacity. On the JRM, large outward swinging doors were installed in the hull, beneath the wings. The final JRM would receive a slight upgrade compared to earlier units. Nicknamed Caroline Mars, this airframe was fitted with Pratt & Whitney R4360s, offering a higher weight capacity. Designated JRM-2, Caroline would set a world record on March 4, 1949, when it transported 239 people from San Diego to San Francisco, California. The Navy would operate the Mars until 1956 before retiring the remaining 4 airframes. They would be put into storage for a few years before being sold for scrap in 1959. Luckily, the Forest Industries Flying Tankers, a newly formed Canadian water bomber company, bought all 4, and the sale was completed in December. All 4 airframes would be modified to serve as water bombers, a role which they would serve in for decades. Of the remaining airframes, 1 would be lost during a water bombing mission when the water drop mechanism failed, which left the aircraft unable to climb quickly enough to clear a mountain. A second would be lost when it was damaged beyond repair during a severe storm. 2 airframes remain today, one of which remains stored at Sprout Lake, awaiting delivery to the Pima Air and Space Museum. The second has recently taken to the skies once more, for the first time since 2016, in preparation to be moved to the British Columbia Aviation Museum. While it's unfortunate that the Mars store must come to an end, it stands out amongst our piston giants as the only example to have flown within recent history. Coming in as the smallest of the giants on our list, the Boeing XPBB Sea Ranger is a bit of an outlier. However, it stands out as being the only twin-engine design discussed today. The aircraft was developed as the Model 344 in response to the Navy's interest in a long-range flying boat for operations over the Pacific. Boeing would earn a contract in June 1940 with a total of 57 units ordered. The aircraft would have a wingspan of 139 feet, 8.5 inches, a full 18 inches shorter than the B-29 Superfortress. Seemingly a trend amongst our giants, the Sea Ranger was also fitted with the Wright R-3350 duplex Cyclone. By 1942, the Sea Ranger would take its maiden flight, departing from Lake Washington. Despite its size, the aircraft was praised for its handling characteristics. Overall, the aircraft was considered a success. However, the project was terminated to allow Boeing to focus on development and production of the B-29. The need for long-range flying boats had been reduced by the abilities of land-based planes such as the PB-4Y privateer. As such, only the single prototype would be produced, earning it the nickname Lone Ranger. Under max fuel load of 9,575 gallons of fuel, the aircraft had a theoretical maximum range of 11,000 miles and an endurance of up to 72 hours. Under standard operating configuration, the Seamaster had a range closer to 4,250 miles. Defensive armament consisted of 850 caliber machine guns mounted in 5 turrets. Offensive payload consisted of up to 20,000 pounds of bombs in internal bomb bays, or 2 torpedoes slung under the center wing section. The XPBB would continue to fly with the Navy until 1947 when it was officially retired. After retirement, it was placed in storage at Naval Air Station Norfolk, Virginia. The fate of the aircraft since is unknown, however, it was presumably scrapped shortly after. Development of the largest combat aircraft in history would begin as early as 1941, after the Army Air Corps announced a design competition for a new bomber capable of carrying a 10,000-pound payload to a target 5,000 miles away, with fuel to make a return trip. This was an ambitious and seemingly impossible task, as the then-in-service B-17 could only manage delivery of a 4,000-pound payload to a target 1,000 miles away. Consolidated Aircraft Corporation would submit their Model 35, later redesignated Model 36, and would be awarded a contract for 2 prototypes in November 1951. Delivery of the first prototype would be expected by May 1944, and the second following 6 months later. The Army Air Corps would designate the project XB-36. As the war continued on, production priority was given to the B-24 Liberator. Consolidated was also busy developing the B-32 Dominator as a backup to the Boeing B-29 program. As such, the XB-36 development progressed slowly. By March 1943, Consolidated would merge with Vultee, becoming Convair. Around this time, development of the B-36 accelerated due to fears that the U.S. would lose land bases in China from which to launch the B-29 in raids against Japan. Had these fears come to fruition, the B-36 would have been the only aircraft with the range necessary to strike the Japanese homeland. By mid-1944, the situation in the Pacific had greatly improved, with numerous island bases secured for the now U.S. Army Air Force to deploy their B-29s. Despite this fact, interest in the B-36 did not falter, as the promise of a long-range intercontinental bomber that did not rely on the capture of overseas land bases convinced the air staff that there was still need for such an aircraft. Defensive armament would consist of 6 remotely operated, retractable turrets fitted with dual 20mm autocannons, as well as non-retractable nose and tail turrets. Later models would remove all but the tail gunner. In terms of payload, it could carry up to 86,000 pounds of ordnance. At the time of its introduction, the B-36 was the only aircraft capable of delivering the Mark 17 hydrogen bomb. It was also the only aircraft capable of carrying the 20-ton T-12 Cloudmaker, an extremely large earthquake bomb. Finally, on the 8th of August, the XB-36 was ready to take its maiden flight. Shortly after 10 a.m., the aircraft started its takeoff roll, slowly lumbering into the skies. The flight would take place over Fort Worth, Texas, at an altitude of 3,500 feet and lasted 37 minutes. The flight was deemed successful, with the only mishap being the malfunction of one of the flaps. Later that week, the XB-36 would take a second flight, lasting just shy of 3 hours, this time without fault. Not all early test flights would go so smoothly. As testing continued through fall of that year, numerous difficulties involving engine cooling and propeller vibration would reveal themselves. In an attempt to keep the weight down, an aluminum conductor was chosen for the electrical system instead of the more reliable but heavier copper. The aluminum wiring had poor fatigue characteristics and would result in numerous failures of the electrical system. Although not entirely solved, most of these issues would be at least reduced to an acceptable standard through various modifications. As the B-36 program was behind schedule and plagued with problems, the Navy accused Convair of diverting congressional funding from naval aviation. The Navy would push to cancel the program to reallocate funding for the USS United States Supercarrier program, which itself was later canceled. By 1947, the first production B-36A would roll off the assembly line, and by 1948, the B-36 Peacemaker was accepted into service. The name Peacemaker was an unofficial name given to the aircraft to represent the intent of the aircraft. The hope was that such an aircraft could obtain peace by deterring conflict, mirroring Roosevelt's ideology of speak softly and carry a big stick. The 7th Bombardment Group of the 8th Air Force would be the first operational unit with the B-36. The 7th Bombardment Group previously operated the B-29 Superfortress, which was then classified as a very heavy bomber. With the introduction of the B-36, the B-29s still in service with the 7th Bombardment Group were reclassified as medium bombers, as the B-36 took on the title of heavy bomber. Even after refinements to the XB-36 were made to resolve the various problems it faced, the B-36As in service were also plagued with their own teething issues. The mechanics had their hands full with hydraulic leaks, exhaust system failures, fuel leaks, and electrical failures. On top of this, as the B-36A was still in the early stages of production, parts were somewhat scarce. In service, the B-36 proved to have some unique flight characteristics. Due to the extremely large wing and, in later models, the supplemental jet engines, the aircraft had a wide margin between stall speed and maximum speed, especially at high altitudes. Capable of flying above 40,000 feet, the B-36 actually proved to be able to outmaneuver early jet interceptors, who were not as effective at such high altitudes. By 1950, however, Soviet MiG-15s appeared over Korea. The capabilities of the MiG rendered Piston bombers obsolete as offensive weapons. This would result in Convair attempting to create an all-jet-powered version of the B-36, designated YB-60, which lost out in competition to the Boeing B-52. By 1956, the USAF slowly began to scrap the B-36s in service, replacing them with the Stratofortress. 2 years later, a series of budget cuts would slow B-52 production, forcing the B-36's service life to be extended slightly. Of the 384 units built, only 22 were still operational by December 1958. The last flight of the B-36 would occur in February 1959. A B-36J would depart Biggs Air Force Base in Texas and flew to Amon Carter Field in Fort Worth, where it was put on display. In the end, only 5 would find themselves in museums, with the rest being scrapped. A single B-36 would be modified into a heavy transport for the USAF. This transport would be capable of lifting over 100,000 pounds of cargo or 400 fully equipped soldiers in a double-deck configuration. Designated XC-99, this aircraft would first fly in 1947. After a few years of testing, it would be accepted into service, flying its first cargo mission in 1950. This mission, called Operation Elephant, would conveniently see the aircraft transporting engines and propellers from San Diego to San Antonio for the B-36 program. The USAF determined that they had no need for such a large transport aircraft and decided not to order the XC-99 into production, but continued to fly the single example through 1957. During its operational life, the XC-99 logged 7,400 hours of flight time and transported more than 60 million pounds of cargo. Its last flight would be conducted in 1957, where it was flown to Kelly Air Force Base in San Antonio, where it would reside for the next 47 years. Convair would propose a passenger variant, designated Model 37, of which Pan American Airways would order 15. However, the skyrocketing cost of operation caused Pan Am to pull out, hoping for a more efficient turboprop-powered version to be ready. The turboprop power plants did not materialize quick enough, resulting in the passenger variant being abandoned by Convair. In 2004, the aircraft would be disassembled and moved to the National Museum of the USAF, a process that took 4 years to complete. While there are restoration plans for this aircraft, there is no practical timescale on which it could be done. To preserve the aircraft from further decay, it was slowly moved to storage in Tucson, Arizona. Currently, the museum lacks the resources for restoration. The Lockheed R6V Constitution began in 1942 as a joint project between the Navy, Pan Am, and Lockheed to develop a true land-based heavy-lift aircraft. The agreement between Pan Am and Lockheed was for an aircraft with a 5,000-mile range, a payload capacity of 17,500 pounds, and a cruise speed above 250 miles per hour. The Navy would soon agree on the specifications and issue a contract in November 1942. The Lockheed Model 89, as it was initially designated, would sport a double-bubble fuselage design allowing for easier cabin pressurization. The chosen power plant was a configuration of 4 Pratt & Whitney R-43 60-18 Wasp Majors, each producing in excess of 3,000 horsepower. Early proposals included a steam-driven supercharger, which was eventually dropped in favor of a more conventional exhaust-driven supercharger. It was believed a steam-driven supercharger would have provided superior performance. However, development time and costs precluded its use. Construction of the Constitution would progress slowly, as the project was not given a high priority status during the war. Further slowing development was the need to build a new 6-story hangar capable of storing such a large aircraft. The first prototype, designated XR60, would be rolled out of the factory on August 17, 1946. Almost 3 months later, on November 9th, the Constitution would take its maiden flight. This flight would last 2 hours and 17 minutes as the aircraft flew from Burbank to Murdoch Army Air Base, where it conducted 2 takeoffs and landings before returning to Burbank. During this flight, the Constitution would record a top speed of 303 miles per hour. During its flight testing, the XR60 proved to be underpowered. In an attempt to solve this issue, newer R-43 60-22W engines were installed. With water injection, these new engines could produce 3,500 horsepower. These engine changes necessitated a change in the propellers as well, swapping the 19-foot Curtiss electric props for a smaller 17-foot prop, borrowed from a USAF B-50. After a year of test flights on the first airframe, the second XR60 prototype was ready to be flown. In contrast to its sister ship, the second prototype's upper deck would be fully furnished as a luxury passenger transport, with accommodations for 92 passengers and 12 crew members. The lower deck had over 7,300 cubic feet of cargo space, which could also be converted to seat an additional 76 passengers. The Navy initially placed an order for 50 units. However, the end of the war led to a change in priorities, and the order would be canceled. Only 2 prototypes would be built. Despite the cancellation, both airframes would see use by the Navy after the testing phase. The first airframe would be delivered to Navy Transport Squadron 44 and would regularly fly between California and Hawaii. The second airframe would fly a similar route, but would also be used during a Navy recruiting tour in 1949. During this period, it would tour 19 cities, where over 500,000 potential recruits toured the interior. Lockheed, realizing the aircraft needed more power in order to be a viable contender in the civilian market, proposed a new version, Model 289, which would take advantage of the Wright XT-35 Typhoon turboprop. This proposal never got off the drawing board, as Pan Am favored the new Boeing Model 377. While the Navy made good use of the two airframes, the aircraft still proved to be underpowered and continued to suffer engine cooling issues. By 1953, the Navy would retire both airframes as they could no longer afford to keep them flying. After the airliners failed to express any interest in signing a lease to operate these aircraft, the Navy would put them both into storage in Arizona until 1955, when both airframes sold for just under $100,000. One airframe would see itself used as a billboard in Las Vegas for Alamo Airways, before being scrapped by billionaire Howard Hughes in 1970. In 1963, the second airframe was sold to a German buyer with plans to fly it to Barcelona to be converted into a restaurant. The night before its planned departure, the aircraft was fueled and ready for a morning flight. However, come dawn, it was discovered that the aircraft was damaged by an internal fire in a case of suspected arson and possible insurance fraud. At this point, the airframe would once again be put in storage where it would stay until it was scrapped in 1970. At last, we come to the largest piston design the world has ever seen, and perhaps the giant with the most convoluted history as well. Howard Hughes's H-4 Hercules, often known as the Spruce Goose, was made almost entirely of birch, not spruce. A less endearing, though more appropriate nickname it earned was the Flying Lumberyard. In 1942, Allied shipping across the Atlantic Ocean was suffering heavy losses to German U-boats. In response, the U.S. War Department issued a requirement for a strategic airlifter capable of carrying a large payload across the Atlantic. However, due to wartime priorities, the aircraft could not be made of aluminum or other strategic materials. Howard Hughes would team up with established shipbuilder Henry J. Kaiser to work on what they would call a flying cargo ship. To reflect the collaboration between the two, the aircraft would receive an initial designation of HK-1. Hughes would be in charge of the design process, while Kaiser would utilize his shipyards in the construction process. A total of 7 configurations would be proposed, including twin-hull designs and a combination of 4, 6, and 8 engines. The final design would be a gargantuan 8-engine flying boat with a monstrous 320-foot wingspan. Even with the large quantity of engines, the design called for the most powerful available, resulting in the selection of the Pratt & Whitney R-43 60 Wasp Major. It was designed to carry 150,000 pounds of cargo, 750 fully equipped troops, or 2 M4 Sherman medium tanks. As can be expected, the project ran into multiple delays. Part of this would be due to the restrictions placed on the acquisition of strategic materials such as aluminum, but the project would also run into complications due to Hughes's insistence on perfection. Construction of the first prototype would not begin until 1944, 16 months after receipt of the development contract. Frustrated by the delays, Kaiser withdrew from the project, and the aircraft would be redesignated as H-4 shortly after. The Hercules would continue to fall behind schedule, not being completed until well after the war ended. Finally, by November 1947, it would be ready for its maiden flight. During a series of taxi tests on the morning of November 2nd, the H-4 would briefly become airborne after accelerating to a speed of 135 miles per hour. The flight would last all of 26 seconds and never exceeded 70 feet of altitude. To this day, there is much debate as to whether or not the aircraft was actually capable of flight, as it never left ground effect during the demonstration. To Hughes himself, the brief hop was enough to demonstrate that the aircraft was indeed capable of flight, and thus an appropriate use of government funding. Due to the delays, there was a certain amount of controversy behind the aircraft, with some accusing Hughes of taking advantage of military funding for a personal endeavor. That, however, is a story that we will not go into today. While the H-4 would never fly again, Hughes hired a full-time crew of 300 workers to maintain the aircraft in secrecy in a large climate-controlled hangar. After Hughes's death in 1976, the U.S. government would reclaim the aircraft. Eventually, the aircraft would be acquired by the Evergreen Aviation and Space Museum in Oregon, where it continues to reside today. While Hughes was responsible for the scrapping of the previously discussed Lockheed Constitution, without his efforts preserving the H-4, it's very likely the aircraft would have been scrapped as well. Curiously, the hangar which Hughes stored the Hercules in was later converted into a soundstage, where movies like Titanic were filmed. While irrelevant to the story of the Spruce Goose itself, I found that to be an interesting tidbit of history, as the H-4 could be considered the Titanic of the skies. For decades, the H-4 would remain the largest aircraft in the world, by wingspan. While large jet-powered aircraft like the Lockheed C-5 and Antonov An-225 were larger in overall size, it would not be until 2019 that the H-4 would lose the title of longest wingspan to the twin fuselage-scaled composites Stratolaunch. With a monstrous wingspan of 384 feet, Stratolaunch was 21 feet wider than the Saturn V rocket was tall. When pushing the limits of aviation technology, you're bound to run into problems regarding technological limitations. When asking the question of just how large can you build a piston aircraft, there is no definitive answer. With modern technology and manufacturing techniques, it's likely possible to build bigger than ever before. The limiting factor quickly becomes practicality and cost. Most of these giants were more trouble than they were worth, but each one has earned its place in history.